Hello, my name is Lallawmsangi. I'm a first-year graduate student from Department of Chemistry and Biochemistry at University of Texas, Arlington. I'm going to talk about the synthesis of potassium-binding Lewis-based chiral catalyst. The goal of this design is to synthesize chiral Lewis-based catalysts for the development of an efficient and selective methods for the synthesis of chiral non-racemic molecules, which is one of the most important tasks in contemporary organic chemistry and drug discovery. To the best of our knowledge, transition metal-free enantioselective branch selective hydrosilylation is unknown. In our previous work, we have developed a Lewis-based catalyzed complexation-induced head using hydrosilane and potassium third butoxide as a Lewis-based catalyst to give highly regioselective Markovnikov product. We envisioned to develop enantioselective branch selective hydrosilylation of alkenes using a chiral Lewis-based potassium binding catalyst. And the three catalyst has been synthesized as three components. The first part is the chiral element, vinyl-based chiral backbone, and the second part is the potassium binding fragment, such as 18 crown 6 ether, and the third part is the Lewis base, and one arm of vinyl can hold aziridine crown 6 ether, and the other arm can contain alkoxide for head. Both the alkoxide and the potassium binding fragment are in the same molecule, so we expect that this salt bridge structure of pi potassium silicon Lewis base would guide the fast and selective cross radical, preventing the loss of a Lewis base. We synthesize one aziridine crown 6 ether from tetraethylene glycol disulfonate and diethanolamine, and we use this prepared one as a 18 crown 6 ether as a starting material. And with the model study in hand, we first react with trifosgene to form the desired carbomoyl chloride, followed by the addition of R-binyl to furnish the coupling product. The substitution reaction with ethylene carbonate under basic conditions can afford this alcohol, and we can insert the potassium and get the potassium binding Lewis base catalyst. And the primary precursor for the Lewis base potassium binding catalyst has been synthesized, and after we complete the synthesis of this catalyst, we will investigate the catalyst for enantioselective selective hydrosilylation. I would like to acknowledge NIH and NSF for funding this project. Thank you very much.